ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Hello students, now let us continue our discussion about factors affecting photosynthesis. Now if you look at, for the last class we studied the factors are divided into external factors as well as internal factors. So we divide them into two, external factors as well as internal factors. If you take the external factors in that we have discussed about the light. So if you look at the light, what are the three important aspects of the light? So we take light intensity and the light quality as well as duration of light duration. So these three things, these three parameters we have studied for the last class. When we study the light intensity, importantly we have studied about what is called as carbon dioxide compensation point. Very important. Compensation point. Where you find high carbon dioxide compensation point for C3 plants? Where you find low carbon dioxide compensation point for C4 plants? So at light intensity at which photosynthetic uptake of carbon dioxide equal to respiratory output of oxygen, and that point itself is called carbon dioxide compensation point. Very important for all of you to remember. When carbon dioxide compensation point achieved or happening at that point, at that process, growth does not happen in case of plants. That is a very important point we have to remember with light intensity. Right. Now what is the next factor? In external factors, we are in the discussion about the second one. The second one is nothing but what? Temperature. Right. So but before we talk about the temperature, now if you look at the light part here, for example you are drawing the light here. So you are taking the graph, rate of photosynthesis on y-axis or on x-axis, and we are taking light intensity on x-axis. Then what happens here? So when light is increasing, rate of photosynthesis also increases, but at highest light intensity, rate of photosynthesis becomes constant. So there is an increase in rate of photosynthesis, as light is also get increased here from A to B. At highest light intensity, the rate of photosynthesis becomes B to C, where rate of photosynthesis becomes constant. Why rate of photosynthesis becomes constant here? Why it is constant? Because in this case we say that rate of photosynthesis is constant. Why? Because the process, because of solarization, or we call photooxidation. What is solarization or photooxidation? It's nothing but what? Destruction of chlorophyll. So there is a destruction of chlorophyll A. Right. So when the light intensity is increasing, rate of photosynthesis also got increased from A to B. Right. But B to C, rate of photosynthesis becomes constant. But you know, light intensity we always study in terms of with carbon dioxide. So light intensity we always study with carbon dioxide. Generally if you take the light rarely becomes limiting factor. Light rarely act as limiting factor. Light rarely act as limiting factor. Okay, that means light generally it is available forever for the plant. Very rare exceptional cases like the plants which grow in dark regions. Only for those plants, if you leave it aside, for most of the plants for plenty of light is available. So light rarely act as limiting factor, means light cannot stop the process called photosynthesis. When it stops, when the light is beyond the limit, when the light is beyond the optimum light intensity, at that time photosynthesis becomes constant. Generally light will not inhibit photosynthesis, it will not act as a factor for stopping the photosynthesis, only it makes the photosynthesis constant beyond the optimum light intensity. Then mostly who act as a limiting factor? Mostly carbon dioxide act as limiting factor. Mostly carbon dioxide act as limiting factor. How carbon dioxide act as limiting factor and how carbon dioxide along with the light, how they influence photosynthesis, we will study in the coming concept. In this class only we will study, but try to remember light and carbon dioxide both plays very important role for the photosynthesis. The most important factors are nothing but light and carbon dioxide, but in this light rarely act as a limiting factor. Most of the times light favors for the photosynthesis to happen, but most commonly carbon dioxide act as a limiting factor. That means in plants for decline in photosynthesis, the most common factor responsible is nothing but carbon dioxide. Carbon dioxide and light, how they influence photosynthesis, we will discuss in the continuation of this topic, right. So where are we in external factors? We were discussing about the temperature for the last class. Okay, so what we have discussed here, so if the temperature is increasing, temperature is low temperature, we start writing that, we say low photosynthesis, PS meaning what? Photosynthesis, PS meaning photosynthesis. Then at optimum temperature, we find high rate of photosynthesis, or we say photosynthesis is maximum, meaning photosynthesis occurs at a highest rate with the optimum temperature. What is optimum temperature? The optimum temperature vary from one plant to other plant. For example, if you look at, because optimum temperature itself is favoring what? High rate of photosynthesis, right. So in this case if you look at, now temperature optimum we are taking, optimum temperature we are taking, you know, for C3 plants and for C4 plants. For C3 plants the temperature optimum is 18 to 25 degrees centigrade, and for C4 plants the optimum temperature is 30 to 45 degrees centigrade. Okay, as the temperature increases, rate of photosynthesis also increases in case of what you call C4 plants. But coming to C3 plants, temperature up to 25 degrees, rate of photosynthesis also increases, but beyond 25 degrees rate of photosynthesis becomes constant or it declines. Okay, so temperature optimum for C3 plants is 25, beyond 25 rate of photosynthesis declines. That is why they have low productivity rate when compared with the C4 plants who can produce food and they can continue photosynthesis up to 45 degrees centigrade. That is why C4 plants have high biomass productivity or high rate of photosynthesis. Now, the next and the most important factor, the next one is nothing but third factor, a very important one, it is nothing but what? Carbon dioxide. Now, let us discuss about carbon dioxide. So, if you look at carbon dioxide, we will discuss at the end. Carbon dioxide has lot of role and you know it is very important factor. First let us discuss simple factors, lastly we will take maximum concept of carbon dioxide. So, let us talk about water. So, let us talk about water. So, if you take the water, very importantly we say that if water concentration, increase in water concentration, you know definitely rate of photosynthesis also increases. Obviously, right? Why? Because if there is high transpiration, meaning high loss of water. That means during transpiration, because by applying transpiration pull, the water is taken from the ground, supplied to all parts of the plant, then the plants tend to undergo photosynthesis. So, photosynthesis also increases. But if the water concentration is less, then it decreases the rate of photosynthesis. So, water also plays very important role. Why? Because water here proton, what you call proton donor, and oxygen released here coming from water, not from carbon dioxide. So, here water act as the proton donor. It acts as a proton donor. That is why water is very important. So, water has plenty of water, rate of photosynthesis increases, and high transpiration it causes. If water concentration is less, automatically it declines the rate of photosynthesis, because water is a contributor of photon donor, as well as it releases from water, releases oxygen. So, even water is a contributor of oxygen, very important. So, you know, according to Cornelius von Neel, oxygen is coming from water, not from carbon dioxide. Carbon dioxide is reduced to form carbohydrates, right? That is what we have discussed. Now, apart from this, let us go with the next one. Let us take the next one as oxygen. You know, the oxygen is said to be a least factor which controls photosynthesis. Oxygen is referred as the least factor which controls the process of photosynthesis. Why? Because oxygen is produced as an end product in photosynthesis, because oxygen is considered as a end product which is produced in the process called photosynthesis. Where oxygen is produced? In non-cyclic electron transport system. Where non-cyclic electron transport system occurs? Non-cyclic electron transport system occurs in the light reaction. So, in non-cyclic electron transport system, splitting of water, where splitting of water occurs? Splitting of water occurs in the grana. Where in the grana? That is nothing but lumen of thylakoid. So, the site or location of oxygen release in photosynthesis, if at all the question comes, if that question comes, then we say splitting of water when it occurs in the grana. Where exactly in the grana means in the lumen of thylakoid. Photolysis of water occurs, splitting of water occurs and releases oxygen out. And who is the contributor for this? The contributor for this is PS2, itself is also called P680. This is when the oxygen is released. But what else we studied? You know that we studied what is called Warburg effect. Warburg effect. Warburg effect. What is this Warburg effect we have studied for the last class? Generally oxygen acts as a least factor. Means oxygen in normal concentration, you know that oxygen in the atmosphere, it is contributor, second important gas, second major gas is oxygen. The percentage in the atmosphere is nothing but 21%. Generally oxygen concentration is low, it is a least factor affecting photosynthesis. Generally it will not affect photosynthesis. Very rare, very less impact will be there on photosynthesis if you take into consideration of concentration of oxygen. But simultaneously, you know the discovery of Warburg, and you know what we have studied for the last class as Warburg effect. What is a Warburg effect? So, according to here, if at all general concentration of oxygen will not affect photosynthesis, but if at all, if the oxygen concentration increases to the drastic levels, then definitely it causes rate of photosynthesis will get declines, rate of photosynthesis decreases. If oxygen concentration increases, rate of photosynthesis decreases. This is being studied by Otto Warburg. It is said to be as Warburg effect. Generally oxygen is a least factor. But whenever the oxygen concentration is more in the surrounding environment, that definitely causes impact on photosynthesis. It declines the rate of photosynthesis. Why it declines rate of photosynthesis? Guys, can you tell me why oxygen, increase in oxygen, why increase in oxygen declines photosynthesis? Can you tell me why? What is the reason? Here, if RUBP concentration is, if oxygen concentration is more, generally it is a least factor. But if the oxygen concentration drastically increases, then what happens? Instead of combining RUBP with carbon dioxide, it combines with oxygen, it undergoes what is called as C2 cycle, or itself is called glyoxylate cycle. Oxalate cycle, and itself is called as what? Itself is called as photorespiration. Itself is called as what? Photorespiration. Photorespiration is also called as what? A wasteful process. Itself is considered as a wasteful process instead of undergoing photosynthesis. You know, if RUBP combines with carbon dioxide, it undergoes Kelvin cycle, nothing but photosynthesis will undergo. It will continue photosynthesis. Suppose if the oxygen concentration is more in the surrounding environment, as we discussed for the last class, RUBP, instead of combining with carbon dioxide, it combines with oxygen and produces what is called as C2 cycle. Itself is called as what? Glyoxylate cycle. C2 cycle itself is also called photorespiration. Itself is called wasteful process. Why do you call this as wasteful process? Because you know it very well. No synthesis of ATP and NADPH2. So this is, in this process there is no ATP is produced, there is no NADP produced, and moreover no synthesis of sugars. Even sugars are not produced, as that is why even this is called as a wasteful process. Moreover, it utilizes ATP. With this process, no use, no ATP synthesis, no NADPH2 synthesis, no sugars are produced. Moreover, to operate this process, it consumes ATP. That is why photorespiration is also called as a wasteful process, where it occurs in case of C3 plants. That is why when generally oxygen in general concentration, in normal concentration, it acts as a least factor. But when oxygen concentration increases, definitely declines rate of photosynthesis. Itself is called as Warburg Effect. Very, very, very important. Right. Next, let us go with mineral elements. Right. Now, let us go with what is called mineral elements. Next one, let us come to the mineral elements. Right, mineral elements. Even mineral elements also come under external factor. It also come under external factor. Now, if you take mineral elements, some mineral elements such as if you take like iron, magnesium, manganese, copper as well as chlorine, right. Suppose if you take some mineral elements like iron, magnesium, manganese, copper and chlorine, you know they are very much essential for, synthesis of chlorophyll. They are very much essential for synthesis of chlorophyll. So, for the chlorophyll to synthesize, you know chlorophyll structure we have discussed, the what you call pyrrole ring, pyrrole 4 pyrrole rings. In the center we find magnesium, iron is there. So tadpole structure of the chlorophyll. For the photosynthesis, the main component is chlorophyll. For the synthesis of chlorophyll, we require the most important essential mineral elements. Not only this, they also play very important role in most of the metabolic processes. Right? Like if you talk about photosynthesis, even they play an important role. Splitting of water, or we call it as photolysis of water. Okay, so I think you remember, even for splitting of water we require manganese, chlorine and all that, right. So mineral elements are very much act as one of the external factors. If these mineral elements are there, chlorophyll gets synthesized in good and proper amount, then photosynthesis they undergo, and also at the same time they play very important role in most of the metabolic processes of photosynthesis, like splitting of water or photolysis. So whenever mineral elements, Me means mineral elements, whenever there is deficiency of mineral elements, if these mineral elements are in deficiency, then definitely that decreases or declines the rate of photosynthesis. Whenever mineral elements are deficient, then that declines the rate of photosynthesis. If these mineral elements are supplied, again rate of photosynthesis increases. So that will come under what? Mineral elements. Now which is the other external, very important external factor left for us? Now you know that carbon dioxide is a very important external factor, act as a limiting factor in coordination with light, but light is rarely act as limiting factor. Let us come back to the first point and let us continue our discussion. Right. So what is the next important factor we have? Carbon dioxide. Right. Now carbon dioxide most commonly act as limiting factor. Now what is meant by limiting factor? We will study once again, we will come back to this point. After you study both external factors and internal factors, once again we will come back to this point, right. Now carbon dioxide concentration, for example, if you take, if the carbon dioxide concentration in the atmosphere, or we say atmospheric carbon dioxide concentration 0.0 to 0.05, right, then that causes rate of photosynthesis increases. If the carbon dioxide concentration increases from where to where? From 0.03, 0.05, rate of photosynthesis also increases. If the carbon dioxide concentration increases from 0.5 to 1 milligram, right, then rate of photosynthesis increases and later it becomes constant. When it becomes constant, beyond 1 milligram of carbon dioxide, rate of photosynthesis becomes constant. That means gradual increase in carbon dioxide concentration 0.03 to 0.05. Rate of photosynthesis increases. Further rise, that is from 0.05 to 1 milligram. Further increase in carbon dioxide also increases the rate of photosynthesis. But beyond 1 milligram concentration of carbon dioxide, then rate of photosynthesis becomes constant. Okay, that means here carbon dioxide is increasing. What we are trying to say here, even this is photosynthesis, PS meaning photosynthesis, and here let us take carbon dioxide concentration. Then it is increases maybe up to 0.03, 0.05 and it keep increasing, but beyond 1 milligram it becomes constant. When it increases beyond 1 milligram, then photosynthesis becomes constant. Right, that means carbon dioxide concentration stopping the photosynthesis after a certain concentration, after certain increase. So, carbon dioxide act as a limiting factor. Anyway, about limiting factor, I will come back to the last point, I will come back lastly. Anyway, I assured you that I will give you this in the last. You will get clarity what is meant by limiting factor at the end of the lesson. Now, let us come to this part. Concentration is keep increasing, rate of photosynthesis also increases, but beyond limit, beyond optimum carbon dioxide, rate of photosynthesis becomes constant. Keep it in your mind. Now, what did I say? Carbon dioxide in coordination with light are the two important factors in controlling the photosynthesis. Let us come back to the first point what we have discussed here. So, we are taking four factors, that is light intensity, then we are taking carbon dioxide concentration, then we are taking C3 plants and we are taking C4 plants. Okay, now we are choosing four parameters. What is the light intensity? What is the carbon dioxide concentration at that point of time, and what is the response from C3 and C4 plants. Okay, so we are taking these four parameters. Now, what do we say here? Suppose at low light intensity is very less, low light intensity, but in surrounding environment carbon dioxide concentration is high, high carbon dioxide concentration. Then what happens? Even though sufficient amount of carbon dioxide is there, but because of poor light intensity, because of low light intensity, neither C3 plant nor C4 plant respond. Neither C3 nor C4 responds, meaning C3 also does not respond and C4 plant also does not respond. Okay, that means what is the statement? Neither C3 or C4 responds. Meaning why? Because light is a very important factor it needed. If there is no sufficient amount of the light, even though carbon dioxide concentration is high, at low light intensity, even though carbon dioxide concentration is high, neither C3 nor C4 responds, meaning C3 plants also does not undergo photosynthesis, does not respond, meaning what? No photosynthesis. Even there is no photosynthesis in case of C4 plants. Why? The reason is low light intensity. Right. Now, suppose if you take high light intensity, we take high light intensity. Right. Next is at the same time high carbon dioxide concentration. See here, both the conditions are favorable. light intensity is high, carbon dioxide concentration is also high. Both are high light intensity, high carbon dioxide concentration. Then rate of photosynthesis. So here in C3 plants also rate of photosynthesis increases. In C4 also rate of photosynthesis increases. In both plants you can see. What we are discussing here? High light intensity. If the high carbon dioxide concentration is there, rate of photosynthesis increases in C3 plants, rate of photosynthesis also increases in C4 plants. Means both plants respond to increase in light intensity. That means light saturation at high carbon dioxide concentration, if you look at, that means how much light is needed to undergo photosynthesis at high carbon dioxide concentration. That means we are speaking about light saturation, right? That is 450 microliters inverse, and that will be 360 microliter inverse for C4 plants. So this is for C3 plants. What is that we are speaking about? Light saturation at high carbon dioxide concentration in coordination with carbon dioxide. How much will it be? 450 microliter inverse. The light saturation at high carbon dioxide concentration in C3 plants, it is 450 microliter inverse. Very, very important. Coming to the light saturation in coordination with carbon dioxide, means the amount of light absorbed by C4 plants, it will be taken as 360 microliters inverse, or you can write capital L. Even this is very, very important. Means light saturation values along with carbon dioxide in C3, it is 450 microliter inverse. Very, very important. You have a chance of getting this question. And the light saturation in terms of carbon dioxide is nothing but 360. Even this we can expect in the form of a question. Right. Now, when high saturation is there, high light intensity is there, high carbon dioxide concentration is there, carbon dioxide, here I am writing carbon dioxide, high carbon dioxide concentration definitely increases photosynthesis, especially in case of C3 plants. Very, very important. High carbon dioxide concentration increases photosynthesis in case of C3 plants. That is the reason why. So let us take the note point. So this table is completed till here. Now let us take the note point. Now take the note point. This is the reason why. So this is over up to here. The note point here is, as high carbon dioxide concentration increases photosynthesis in C3 plants, that is why in C3 plants like greenhouse crops. Which greenhouse crops? I am writing here. Very, very important. Tomato and bell pepper. Bell pepper. What is bell pepper? Bell pepper is nothing but capsicum. What is bell pepper? Bell pepper is nothing but capsicum. In these two plants, in the surrounding environment, if you provide high carbon dioxide, so it increases yield, photosynthetic yield. It increases photosynthetic yield. Very, very, very important. That means for tomato and bell pepper, the yield increases if at all they are surrounded by high levels of carbon dioxide, and these two will come under what? Both will come under C3 plants. Very, very important note point. Make sure that you try to remember, have a possibility of getting the question. Which are the C3 plants we are speaking about? Tomato, bell pepper. Bell pepper is commonly called as capsicum. Now tomato, bell pepper, generally they are cultivated as greenhouse crops. In this surrounding, generally people will provide high carbon dioxide concentration. Why do they maintain high carbon dioxide concentration? Because high carbon dioxide concentration increases photosynthesis, and that too in case of C3 plants. So, whenever carbon dioxide concentration is high in the surrounding environment, in C3 plants rate of photosynthesis increases drastically. So, especially they have done experiment taking the greenhouse graphs of C3 plants. Which C3 plants? Tomato and bell pepper. Bell pepper is commonly called as capsicum. In the surrounding they provided high carbon dioxide concentration. When they observed, it increases the photosynthetic yield. So, they could able to get more yield from the yield increases. They could able to get more yield from more tomatoes and more capsicum from these two greenhouse graphs. They belong to C3 plant. This is one of the good example that yes, high light intensity, high carbon dioxide drastically increases rate of photosynthesis in case of C3 plants. Very important. Okay. So, if you take carbon dioxide and light, again regarding carbon dioxide we will come back to the last point again. Blackman's limiting factor we say, or Liebig's limiting factor. At that time we will discuss again carbon dioxide. Right, before that we will discuss internal factors. But if you look at this is very important, carbon dioxide, how it acts as a limiting factor we will discuss. But now here we are discussing the coordination of two important external factors. What are they? Carbon dioxide and light. So, if you take the intensities, if you take light intensity, imagine it is low, carbon dioxide concentration is high, then what happens? Neither C3 nor C4 responds. That means no photosynthesis in C3, no photosynthesis in C4, even the carbon dioxide concentration is high, but light is the most important factor. Low light cannot support photosynthesis. Suppose if light is increased at high light intensity, if high carbon dioxide concentration is there, then it is observed that rate of photosynthesis increases in both the cases C3 and C4. Then how much light saturation means how much light is needed to undergo photosynthesis when high carbon dioxide concentration is there. Right. So, in C3 plants the light saturation at high carbon dioxide concentration is 450 microliter inverse, that is very important value you have to remember for C3. Coming to C4, light saturation in C4 along with carbon dioxide, it will be 360 microliter inverse. Very important to remember the values of these two, very important. Then very importantly, when high carbon dioxide concentration is there, when high light intensity is there is a drastic at a time rise of photosynthetic yield observed in C3 plants. Experimentally when they grow greenhouse crops which are provided with high carbon dioxide, especially they took tomato and bell pepper. Bell pepper is commonly called as capsicum, and in these two, because of high carbon dioxide concentration they maintain in the surrounding environment, drastically there increases the photosynthetic yield. They could able to get more yield from tomato and bell pepper. Of course, if you look at C3 and C4, you know that very well, you have understood and studied. C4 plants, you know that they fixes double quantity, double amount of carbon dioxide than C3 plants, this you know, right. That is why C4 plants maintain high biomass productivity, but they lose half amount of water than C3 plants, So, these things are very important, need to recollect because we already have discussed in transport in plants. So, C4 plants always fix double the quantity of carbon dioxide than C3, they have high biomass productivity and they lose only half amount of water when compared with the C3 plants. So, these things you have to remember very importantly. So, I hope you understood the external factors, but at the end we will discuss again carbon dioxide, how it acts as a limiting factors. So, here this is very important for you all to remember how carbon dioxide acts as a limiting factor. Remember this we can study with the help of Blackman's limiting factor. Okay. So, this is being studied by scientist Blackman. According to Blackman, carbon dioxide is the most important factor and it acts as a limiting factor, very commonly act as limiting factor, meaning water, when there is no much water, photosynthesis stops. There is no much oxygen, photosynthesis stops. At that time water acts as a limiting factor, because no water, even the light favors, even the carbon dioxide favors, but photosynthesis stops. At that time water acts as a limiting factor. But most commonly who act as a limiting factor means, most commonly carbon dioxide act as a limiting factor, and that is being explained by a Blackman's limiting factor that we have to discuss under external factors, but it is a very important concept. After we discuss internal factors, again we will come back to external factors. Right. So, that who is a scientist? Blackman's. Try to remember Blackman's. But always you have to remember carbon dioxide in coordination with the light are the two supreme important powers. That is why we have taken light intensity and carbon dioxide as the major factors which governs the process of photosynthesis in C3 plants and C4 plants. Of course, other external factors, if they are favorable like oxygen, water, mineral elements, then only these two act as the major factors for making the photosynthesis to get it happen. So, here this is very important. Carbon dioxide acting as a limiting factor was studied and identified by Blackman's. He has given the concept called as Blackman's limiting factor. We will come back to this point later at the end of the photosynthesis.